Hello, everyone. Thank you for joining to my talk. Today, I'm going to discuss a new feature in of Apache Spark version 3.2. I'm going to discuss new types added to this Spark version. So I'm Maxim Gek. My name is Maxim Gek. I'm a software engineer at Databricks. Also, I'm a committer of Apache Spark, and here you can see a link to my GitHub account. And I should say I am working on this new intervals for the last 3 months, and together with other community members, we developed new intervals that should replace older calendar intervals. And today we discuss more about this new feature. This is agenda for my talk. First of all, I'm going to overview of new intervals and discuss the reason why we decided to add new types. And after that, I will dig to the details of new types, how you can construct, how you can apply some operation like binary arithmetics over intervals and dates and timestamps. So here you can see the link to umbrella ticket, and in this ticket we get together all subtasks regarding to the new intervals, and Spark version 3.2 should come with new intervals, and in the new starting from the new release, we wouldn't recommend to use older type, calendar interval type, and probably in the next version it will be deprecated. Calendar intervals. This type was added a few years ago. You can see on the slides link to the original PR where we replaced just regular microsecond columns by new types and mention, for example, one of the Spark committers, he added a new type, interval type. Later, this type was renamed to calendar interval type to not intersect with this type from the SQL standard. And why? What was the reason to add a new type? Because you know, each month in the year has a different amount of days, right? And to give users ability to add just change their only month field, we cannot just add, for example, 30 or 31 days. So if you want just add a couple months, you should be able to say to Spark, I'm going to add exactly 2 months, not 60 or 62 days. So that's why we added new types to Catalyst type system 5 years ago. But this brings some problems. First of all, new type is not comparable. For example, on the example on the slides, you can see I try to compare the subtraction of 2 days with interval of 1 month, and Spark complains it cannot compare because you know, if we even have intervals of 30 days and interval of 1 month, we cannot say this intervals is the same, right? Because months can have different amount of days. That's why Spark currently before version 3.2, Spark doesn't support comparison of intervals. Another problem is even if you cannot compare intervals, you cannot order intervals. Unfortunately, for example, here I created table with 2 columns of date type, and try to subtract an order by subtraction. So, and here also Spark wasn't able to order because current calendar interval type doesn't support ordering, sorting, and so basically because we cannot exactly say 2 intervals, one interval is bigger than another or not. This is 2 fundamental problems, and that's why we decided to add new types. So another problem is currently calendar interval types cannot be persistent to the external storage. You cannot, for example, store it to the Parquet or Org or even some text formats like JSON or CSV. Also, currently, calendar intervals has 3 fields. It's 2 fields of int type, amount of year, months, and separate field for amount of days, and 1 more field for microseconds. And in total, if you count, so each record of calendar interval types consumes 12 bytes per value. This is pretty huge. So comparing to other primitive types. And another problem is current interval type is not compatible to SQL standard, unfortunately. If we look at the SQL standard, and you can see the standard defines 2 interval subclasses, two interval classes. First class, it's called year-month interval. So it's especially to represent 2 combination of 2 fields, year and months. So another class is for days plus time part, like hours, minutes, seconds, plus fraction of seconds. Recently, we added to the this new catalyst types to the Spark master, and here you can see a screenshot from my PR. And these 2 interval types will be released soon in version 3.2. So it will be available to users. You can test them. And so yeah, if we look at the SQL standard, so SQL standard defines intervals as a combination of fields. Year-month interval, this is a pair of 2 fields, year and months. So months field has restrictions, so it can contain only numbers from 0 to 11, so this is obvious. So year depends on how you internally, how many bytes you allocate for intervals. Currently, Spark stores year-month interval as a integer. So that's why it actually has some restriction for year field. So daytime intervals, it's a combination of day, hour, minute, and second, where second can have a fraction. And standard doesn't actually predefines the precision. So and Spark, because Spark supports timestamps with a precision of microseconds, we decided to support by default datetime intervals with precision of microseconds as well. So new catalyst types. So as I said before, precision of year-month intervals months, and precision of datetime intervals microseconds, and both types are comparable and orderable. And the first one, I mean, year-month interval stores internally values as integers, so it consumes just 4 bytes per value. And datetime interval type stores as a long, and one value has a size of their 8 bytes. And on the slides, you can see minimal and maximum values. So this is some kind of consequence of our decision where and how to store intervals. Basically, there is 3 options how you can actually create intervals. First option is from interval strings, and here we strictly follow SQL standard. So you can start from the interval keyword and in the string in quotes define the value of interval and some kind of at the end suffix of interval specification. So it's year to months or day to seconds. Standard supports another units, but Spark currently supports only this kind of units. So probably in the future versions we extend units types and will support also, for example, hours to seconds or minutes to seconds and just years or just months. And another options is how we can construct interval columns is from external types. Year-month interval could be constructed from the collection of Java time period instances. And when we receive values externally inside Spark, we just take 2 fields from this Java class, only year and month, and reject and just keep day field. Regarding datetime interval, we Spark accept Java time duration class values, and because the duration internally support seconds precision up to nanoseconds, but Spark internally just supports only microsecond precision. We just cast and round second fractions up to microseconds. Third option is constructing interval types from integral columns. Like currently we have a function make interval for calendar interval type. It accepts 7 fields as far as I remember. But for new intervals, we have overloaded versions. First one will accept only 2 arguments. First one for year, second one for months, another one for datetime intervals. This feature is not supported yet, but we are going to implement it soon, I hope. this you can see the table of operations over intervals and dates and timestamp this operation are required by your SQL standard. And if we are going to say we conform to SQL standard, we have to support all these operations. Here you can see all possible combinations which will be supported in Spark 3.2. I would so we actually follow in almost in all cases, probably except one, where we add and subtract daytime intervals from date. Here on the slide, you can see behavior of Spark 3.1. You can see if you add a daytime interval to the date, it just returns date, it just rejects the time part. In Spark 3.2, we decided to not reject time part, and because from our point of view, there's some kind of losing information from the user information, which is not appropriate, we think. And if you don't like such kind of behavior, you can actually ask Spark to return old type, calendar interval type instead of ANSI types. If you set this SQL config to the false, it will impact on the subtraction of dates. Also, it will influence on the parsing ANSI interval literals. So in the example, you can see interval literals in ANSI format. So previously we converted such kind of literals to the calendar interval type, but starting from the version 3.2, we will convert it to the daytime interval type. I should highlight some corner cases. For example, usually in some countries, like in the United States, they have two periods in the year, winter time and summer time. And for example, recently United States switched from the winter time to the summer time and moved clocks further by one hour. And if you look at the example, so I added to the some timestamp interval of 2 years, and actually the result stands stands almost 3 hours instead of two hours, as you would expect. So basically, we just some kind of added physical duration instead of logical one. So here we follow the behavior of previous intervals, and we some kind of I cannot say we don't follow SQL standard, because in SQL standard there is no definition of time zone. There is a definition of zone offset. So in SQL standards there is no such problems. Next one. So how, as I mentioned before, we can construct intervals from external types. So, and if you want to, for example, construct a year-month interval, you can use a collection of Java time period. So you can see on the slides the example. And another, on the right part, I constructed a daytime interval from Java time duration. So so because Java time duration has resolution of up to nanoseconds, but Spark internally just up to microseconds, we have to cast duration in nanoseconds to microseconds. You can see this on the slide. Another, as a consequence of supporting external Java type, you can construct, you can use these types in user-defined functions, in user-defined aggregate functions. You can apply such functions to the year, months, and daytime interval columns and change it using Java code or Scala code. On these slides, you can see how you can create tables with new types. So SQL standard says you can define intervals with different units, and it supports many options. But currently, starting from version 3.2, Spark will support only two type of intervals. On the left side, you can see year, months interval type, and on the right side, interval day to seconds. So this new feature is still under development. So currently we almost finished milestone 1, where we try to have feature parity with existing calendar interval type. We implemented serialization and parallelization of external collections and casting strings to interval. We implemented all binary arithmetic operation over intervals and timestamps and dates. So, and currently Spark can keep can support almost all features of calendar intervals, and on the milestone 2, we are going to support creation of external table and store such tables to the data sources, to Parquet, JSON, to all built-in data sources. Support SQL operations like insert, select, update should be all supported. Also, we are going to support partition discovery with new intervals. Currently, this is not possible. And all this work, so we actually need some help from the community. So I would ask anybody who watching these talks to look at this umbrella Jira and take some subtask and help us in developing a new feature. So, and in milestone 3, so we almost implemented all the features. Currently from milestone 3, we support access to the tables with new intervals from via Thrift server, via JDBC. Currently, we return new intervals as a strings because we think this would be easier for our users. On the milestone 4, so we need a deeper integration with other front ends. Like we need to support Python UDF and return intervals to Python. Also need to support R probably. So all this tasks need your help from Spark community. Yeah, that's it from my side. Thank you for joining to my talk. Thank you very much.